All right. So variables. We're going to start at the beginning. We're going to ramp up. Variable. You basically are declaring a variable to identify a memory space on the computer to store data. You can think of it as a bucket that you put data in. You, as the programmer, get the choice of what to name it and what type of data to put into it. Okay. Naming is easy. Type of data, that tends to be where people start to get a little hung up. So, within the C# language, as you probably saw in Java and a lot of other languages, you have primitive types. Primitive types means that they come along with the language. They're pre-created for the language. They're very simplistic. So you have things like integers, booleans, long, shorts, bytes, strings, chars, and objects. Those are all C# primitives. Then we step up a notch, and then within the .NET framework, we have another series of classes. Form, DB connection, HTTP request, task, list, hash table, data reader, data set, XML document, and any class you create is considered a data type. So if you create a class, that is essentially a data type that you can use to create a variable. Data types and variables are best friends. So they always go next to one another. So integer x, string first name, student, my student. The items in blue are your data types. Please feel free to close that door. Items in black are, just close it, they can knock. They're like more than a minute late now. They're like 2 minutes late now. Items in blue are your data types. Items in black are your variable names. Hopefully this is kind of gelling for you again. The top two, just again, kind of point of reference, int and string are our primitives. Those kind of come along for the language. Ints hold whole numbers. Strings hold strings of text in quotes. Student is a class that I would have had to create. That does not exist as part of the .NET framework or a primitive type. Functions. You basically have 3 or 4 types of functions. I listed 3 here, but you have, I guess maybe let me kind of take it this approach. You have a particular syntax or format for any function definition. So you have the what's called the accessor, which I'll get into in a moment. The return type, what is this function going to return when it's called by another piece of code? The name of the function, and then any parameters or data that you want, or variables, if you want to think of it that way, that you're going to pass into that function for it to do its work. So this one, void, returns nothing. So when you call save changes, you don't have to pass anything to it, and it doesn't return anything back to you. It just does some internal work. Public void load user, the method name or function name is load user. It returns nothing, but it takes in a user, it consumes a user, and then does some work with that user. Public user get manager doesn't take anything. The parameters, the area between the parentheses is empty, but it returns to you a user object, so an instance of this class. Okay? Is this all familiar? You're like, yeah, I've seen this? Okay, good, you should. All right, classes. Classes are generally nouns that persist inside of your business logic or part of your business model. So if you're writing a program for a financial institution, you're writing a piece of banking software, your classes will probably be things like cash, bank account, credit card, whatever types of things that you would have inside of a banking application, you would most likely create a class for that. Business, transaction, those types of things. So this is a student class that I referenced on the previous slide. So I have things like private variables, methods, properties, and events. These are all considered the members of the class. So if I talk about class members, or if you get an exception that talks about class members, it's talking about one of these things. And these are the only things you can declare inside of a class, by the way. These 4 types of things. They don't all have to be private strings. They can be private whatever, your declaring variable, int, so forth. Methods, we just covered those. Properties, so if you think back to Java, you always had your gets and your set methods that you'd use to get and set data from an object. Properties are kind of the evolution of that.
So instead of writing these methods that say get and set all the time, wouldn't it be nice if we could just do student ID equals whatever, and set the student ID variable that way? It reads a lot better than set student ID and passing in a parameter.
So this notation we'll talk about more, these properties. And they kind of give you a different experience in the Visual Studio and the IDE. And then events. You can actually create events so that when your class does something, and we'll get into this a lot with the WinForms design, when your class does something, it raises an event, and then you, from another piece of code, can latch onto that event. So when you're done loading a student, you can tell the other code, okay, the student's loaded, now this code can go on and do something else. Or, hey, I clicked this button, oh, the button was clicked, that was the save button, I should go run the save code. So it's that concept of event-driven. When an event occurs, I do something. These are the accessibility levels I was talking about a moment ago. And what this does is it allows you to describe in your code what level of access different other pieces of code have when they're calling into your class. So you create a student, for example. Let me back up here. This is probably a better scenario. So this private string name from another piece of code elsewhere that's using my string class, it cannot see this name variable. It doesn't exist as far as it's concerned because it's private, which means that only methods, properties, and events within this class can see anything that's private. You can have private variables, you can have private functions, you can even have private events and private properties. So anything that's marked as private is only accessible by another method that's public or a property that's public. And they can also be private, so it's kind of interchangeable, but it's only within that class. Outside code cannot call anything labeled private. It cannot call anything labeled protected unless it's inheriting that class. And then you have this idea of a friend or an internal, and I'll get into that in more detail. That has to do with scope of the project and what pieces of your project can see other pieces. Oh, scope. All right. That's a really terrible picture. I should have picked something else. All right, disregard that. So the idea of scope is what can you see? That's what I was getting at with this. So what can you see, or what can your code see, or what can other pieces of code see? So when I taught the Java class, one thing I tried to make people realize is that you're not coding in isolation. You need to try not to think about the fact that you're coding in isolation. You're not writing a program just for yourself. You're writing a program for someone else. And potentially you're writing code that other people may end up using. And we'll get into that in a lot more detail in this class about building class libraries or building code modularly so that you can kind of treat them like Lego blocks and plug them together. But when you start to do things like that, you want to make sure that you're protecting the right data and you're only exposing or presenting to third-party code what you want it to see. If you have a property for your bank account class that actually tracks what the current balance of the account is, you don't want any piece of code to be able to go in and just say, oh, that bank account balance isn't negative $100, it's plus $1 million. You want it to have to call the transaction or add transaction method and prove that there's money being added to the account, and then internally it keeps track of that account balance. Does that make some sense? So you want to have certain pieces of data protected so that not anybody can go change it. So we'll get into that more as we get into the class. All right. The second half of this presentation, I did it last term, and I think it put people to sleep, so I'm not going to go through all of these slides. But if you're interested, it's on Blackboard. I go through and just talk about some of the keyword definition changes, differences. So things like in Java, you have what's called a super. So if you inherited from another class and you wanted to call a method or a function off of another class that you inherited from, you would say super dot that function name. And here we use the term base. Booleans are called bool in C#. You don't have a package, you have a namespace now. And instead of doing an import statement, it's called a using statement. So those are the big ones you probably want to be aware of as we go into this
Beyond that, I've got some other details around is, instance of, constant, read-only, final sealed, private, internal. Those, you can read those at your leisure. Here's a map of all the data types between Java and C# and which ones do and don't exist. There are 4 things in C# that don't match to Java. There's a lot more in Java that don't map to C#, so just keep that in mind. All right. That is my one and only PowerPoint that I'll probably show you the entire term. Any questions? Yes.
Do you not use camel casing?
Camel casing is a good question. The recommended notation is that you capitalize anything that is public. So the first letter of anything public, you capitalize it. Privates, it's up to your discretion. I've seen people that will lowercase the first letter of a private variable. I've seen people, and this is my preference, I'll actually put an underscore, lowercase first letter for a private variable. Beyond that, camel casing is common. So capitalize the first letter, but then camel case after that. So if it's get student, capital G, capital S. But it's not lowercase first letter unless it's private. That is one difference between C# or the .NET languages in Java, is that they do recommend anything public be capitalized. All right. Does anybody not know what camel casing is? I don't know if I need to teach you something if you don't respond. This is what you guys are doing to me. You're like, I have no idea what you're talking about. How you doing?
Sorry.
It's all right. You came right in time for the Bunny with the Penguin concert.
Good. Where's the syrup?
I did not bring syrup. All right. So, this is a class for you to learn. So this is my second rule. I forget my first rule. This is my second rule. Ask questions. Connor asked a question. Thank you, Connor. You notice I've been dealing with the puppy, so. All right. Seriously though, if you have questions, don't be afraid to ask. If you don't have questions, I'm assuming you know everything. And if you're at that point, then come up and see me after class and I'll tell you how to test out. Okay? You guys got stuck with the whole the parking lots are closed, right?
The whole what?
Like the parking lots are closed and they're all about
All
basket.
closed? No, we were just late.
Okay. I appreciate the honesty. Were you guys all together? Okay.
Just coincidence.
Oh, okay. I waited like a whole minute before I started class. I knew there were still 7 people missing, so I was totally just like, no, wait. Nobody showed up. That's cool. All right. Any questions? Questions for the guys that just showed up?
Actually,
Yes.
the text, is that on Safari?
The last I looked, it is not on Safari. That was my one gripe about the textbook switch. So this textbook is not on Safari. So I apologize. Alright. So Blackboard, I'm assuming everyone's familiar with. If not, you can come see me after class. Syllabus is up there. So we'll take a minute and talk about the syllabus. So for the most part, it's standard stuff. Textbook is there. It's the Marach, or however you pronounce his last name, C# 2012. The objectives for this class are for you to be able to create software applications using Windows, .NET, Microsoft.NET, C#. Okay, that's the objective for this class. We're going to talk through object-oriented principles. We're going to talk through ideas of accessing third-party sources of data and then pulling that data into your system. So that means things like databases, web services, socket connections over networks, XML documents, reading from flat files, loading up images, all kinds of good stuff. So we're going to be doing a lot of those things. We're going to touch briefly on creating multi-threaded applications. It's actually a lot easier now than it has been in the past, so we'll touch on that a little bit, and what that all means. and just talk about, again, the data manipulation and all that stuff. Grade scale is pretty standard. The approach for this course, and the rest of it's all normal stuff. So I have a tentative schedule included in the syllabus week by week. Week 8 or week 7's midterms, and then kind of cruising out through the end there. Since we lost a week because of the snow day, I'm going to try to combine these first 2 weeks together. So if I'm going a little too fast, I apologize, but that's my goal so we can keep up. All right, any questions on the syllabus? Yes?
What's the difference from a 90 to 93 and a 94 to 100 in grade?
Are you striving for a 90 to 93 or a 94 to 100?
Even if they'll say A, right?
T minus.
Yeah. Yeah. It's all right. All right, anything else? All right, cool. Okay, so actually let me do this.